talking about the argument from design, which claims that the universe shows signs of being designed by an intelligent mind. Premise 1. The universe is either designed, or the result of chance, or the result of natural law, or the combination of chance and natural law. Premise 2. The universe is not the result of chance or natural law, or the combination of both. Conclusion. Therefore, the universe is the result of design. Now, last week I laid out in very general terms the evidence that suggests just how unlikely it is that a life-permitting planet should exist even in a universe with all the right laws and constants. This week I want to start looking at some of these necessary criteria in more detail. One thing I mentioned last week is that in order for life to exist, you have to have the right kind of galaxy. Now, there are 3 types: spiral, like our Milky Way; elliptical, which are egg-shaped; and irregular, which are just a giant convoluted mess. Now, spiral galaxies give us the best chance of finding a habitable zone. Now, what I mean by a habitable zone is a location within that galaxy that is best suited for life. Take stars, for example. As stars age, they eventually explode in something called a supernova. Now, in one sense, supernovae are absolutely essential for life. You see, the Big Bang produced basically hydrogen and helium, very light elements. But life requires heavier elements. The way these heavy elements are created is they get cooked in stars. Then when those stars blow up, these heavy elements get spread around the galaxy and can eventually come together to form life-supporting planets like Earth. But supernova can also be a curse. I mean, if your planet is too close to a star when it explodes, guess what? The future's not looking too bright for your planet. So you need to be in a region that has enough supernova activity to create all those heavy elements, but not too much so that you're not surrounded by exploding stars all the time. That's what we get with spiral galaxies. Now, you don't want to be too close to the center because there's a whole lot of supernova activity there. Plus, there's a giant black hole at the center of the galaxy that gives off a lot of bad radiation and crushes anything that gets too close. But you also can't be too far out at the edges of the galaxy, because that area doesn't have enough supernova to form all those heavy elements. So you need to be nestled somewhere in the middle. But not just anywhere in the middle will do. You see, spiral galaxies are made up of spiral arms, long arms of stars that twist out from the center. Now, those arms are also overloaded with supernova activity. So the trick here is, you don't want to be too close to the middle. You also can't be too far out by the edge. But you also need to be nestled neatly right in between those spiral arms. But we're not done yet. Your star also needs to have a stable, circular orbit around the center of the galaxy, so that you'll stay in between those spiral arms. See, if your star's orbit is at all irregular, then you're going to cross over some of those arms. And when you do, you run a high risk of getting blown up by all the supernova activity. See, all these factors come together to create a safe zone. But that safe zone only exists in spiral galaxies. In elliptical galaxies, stars have very random orbits, so they visit every region in the galaxy. Eventually, they're going to visit some of the more hostile areas and run into a supernova or a black hole. Not only that, but they also don't have nearly as many heavy elements as spiral galaxies do, so Earth-like planets can't form in them. The vast majority of galaxies in the universe are elliptical, not spiral. The situation's even worse in irregular galaxies. They're so distorted that there are no safe zones. They got supernova going off everywhere. So how many galaxies are there like the Milky Way? Actually, we are in the top 1 to 2% when it comes to the criteria of mass and luminosity. The greater the mass of a galaxy, the greater its gravitational pull, which means that our galaxy, unlike 90% of the others, has the ability to attract those needed heavy elements so that life can exist. We truly live in a privileged place. But that's just part of the story. Next week, we're going to take a look at our star, the Sun. See you then. God bless.